This section deals with solving exponential and logarithmic equations. Let's start by looking at exponential equations. So there are two types of exponential equations that we're going to look at. The first type is exponential equations where both sides can be expressed with the same base. So to solve these equations, we're going to use the one-to-one property. And the one-to-one property says, all right, well, if a to the x is equal to a to the z, so if the base is the same and you're raised to an exponent, then the exponents are equal to each other. Again, if the base is the same and you're raised to some exponents, then the exponents have to equal each other. So how do we solve these? Well, first we want to express both sides with the same base, and then set the exponents equal to each other and solve. So let's look at some examples of this. Example 1, solve the following equation. So the first thing I need to do is express both sides with the same base. Well, I actually have both sides already with the same base. They both have a base of 2. 2 to the x equals 2 to the third. So what do? I can set the exponents equal to each other. In this case, x is equal to 3. Now I need to solve this. Well, it's already solved, so I'm all done. Let's look at example 2. Again, you need the bases to be the same on both sides of the equation. Well, my bases are already the same for this one, so I can set my exponents equal to each other. So I get x plus 1 is equal to 3. Next, solve for x. Well, subtracting 1 from both sides, I get x is equal to 2. So here, x is equal to 2. Example 3. Again, first express both sides with the same base. Well, I don't have the same base right now. I have 3 on the left and 81 on the right. So I need to do a little work here to get them to both have the same base. Well, I know that 81 can be rewritten as 3 to the 4th power, because 3 raised to the 4th power is 81. Now I have the same base on both sides, so I can set the exponents equal to each other. So I get x plus 1 is equal to 4. Solving for x is equal to 3. And let's look at the next two examples. 8 raised to the x over 2 is equal to 4 raised to the x minus 1. Okay, the very first thing I need to do is express both sides with the same base. Well, I can't use 4 on both sides because there's no power I can raise 4 to give me 8, but both can be expressed as 2 to a power. Well, I know that 8 is the same as 2 to the third power, so this is going to be 2 to the third power times that exponent of x over 2, and 4 can be expressed as 2 to the second power, so it's 2 to the second power times x minus 1. Now I have the same base on both sides. I can set the exponents equal to each other and solve. So this is really 3x over 2 equals, distributing on the other side, 2x minus 2. Well, let's say that I don't like fractions. I can start off by just clearing the fraction in this problem, multiply everything by 2 to clear the fraction. Here my 2's cancel, and I have 3x is equal to, distributing in on the right, 4x minus 4. Solving for x, if I subtract 4x from both sides, I get negative x is equal to negative 4. Dividing both sides by a negative, x is equal to 4. All right, let's look at the very last one. We have 4 to the x is equal to 1 over the square root of 2. Well, I have 1 over the square root of 2, so I need to know how to deal with this. Well, remember, the square root of 2 can be rewritten as 1 over 2 to the 1/2. So the square root is the same as the 1/2 power. And if we want to have something not be in a fraction, we can always rewrite it as 2 to the negative 1/2 power. Because remember, with negative exponents, what we would do is move them to the bottom if they were negative in the numerator. So 1 over the square root of 2 can actually be rewritten as 2 to the negative 1/2 power. Well, can I express 4 with a base of 2? I can. I can rewrite this as 2 to the second times that x, and then we have 2 to the negative 1/2. So now set the exponents equal to each other because you have the same base and solve for x. So 2x is equal to negative 1/2. Solving for x by dividing by 2, or dividing by 2 is the same as multiplying by a half. So if I have negative 1/2 times a half, I'm going to end up with negative 1/4. So again, the very first way to solve exponential equations is to express both sides with the same base. Then we set the exponents equal to each other and solve for x. The next video is going to deal with the second type of exponential equations, which cannot be expressed with the same base.